Good day, everyone. We're going to be talking about ovals. Ellipses? Ding! Ellipses are ovals, but not all ovals are ellipses. Mr. Zonka, why you gotta make things so confusing? Alright. For now, just think of the term ellipses. Now, here we've got all the major information for you to use at your convenience, but I want to highlight a few specific things without getting too confusing. One, we can find the center just like we found the vertex of a parabola. It's just going to be the opposite of our x term and the opposite of our y term. So, for example, this center here would be at the value hk, the opposite of x minus h and the opposite of y minus k. Second, notice that all ellipses are not circles, meaning that one direction is going to be longer than the other. We call the longer axis the major axis. In this case, the major axis would be horizontal. In this case, the major axis would be vertical. How do we determine this? Based on which number underneath our x or y term is bigger. So in this case, if a is bigger, we go left and right. In this case, y, the a represents the bigger number. That's going to be vertical, up and down. The minor axis is just the smaller axis. In this case, it's vertical. In this case, horizontal. Moving on, vertices. Vertices are always the major points at the end of your major axis. You can find these by adding your a term to your point, depending on if you're horizontal or vertical. So, anyway, you'll see an example of that. But just know that your vertices are your endpoints of your long side. Your covertices are the endpoints on your minor axis. This is also dependent on your terms that are underneath your x and y squared. To find your foci, you're going to have to find c. C is represented with this neat equation, c squared equals a squared minus b squared, or your big term that's underneath minus your smaller one underneath, and it's kind of like Pythagorean theorem, except you're subtracting, and you add that c point either horizontally or vertically, depending on which is your major axis. Alright, let's move on to some examples. Alright, try to follow along. I'm going to be using my equation along with graphing to help me find everything I need and graph my ellipse. Here we have our equation, x minus 3 squared over 36 plus y plus 1 squared over 9 equals 1. Always equal to 1. First off, center. Center is going to be the opposite of my x, 3, and the opposite of my y, negative 1. Let's go ahead and put that on the graph. 3, negative 1, right here. Next, I'd like to see which of my fraction denominators is biggest. And here we have 36, obviously bigger than 9. This 36 is under the x squared term, so I know my ellipse is going to have a major axis in the horizontal or x-axis direction. If I take the square root of this 36, I'm going to get 6. And you could think of this 6 kind of like a radius from the center. So, since we're going the horizontal direction, I'll count 6 spaces over. 1, 2, 3, 4, 5, 6. And I'm going to have one vertice right here. Let's count 6 in the other direction. 1, 2, 3, 4, 5, 6. And my second vertice right here. This gives me a major axis length of 12 and my vertice points at negative 3, negative 1, and 9, negative 1. Next, let's take a look at our minor axis. This is going to be the denominator under the y squared term in this case since it's smaller. Here we have 9. Take the square root of that. Again, we could treat this like a radius. This time, since it's under the y squared term, it's going to be going in the vertical direction. Let's count our spaces. 1, 2, 3. And another one. 1, 2, 3. That's going to leave us with the minor axis length all the way from one covertice to the other of 6. And my covertices at the points 3, 2 and 3, negative 4. Now that we've got our vertices, covertices in our center, we can just draw our ellipse. To do this, just play a fun game of connect the dots. To find the foci, we're going to use that fancy equation we talked about, c squared equals a squared minus b squared. A simpler way to think of this is just take your big number here, subtract the smaller number, and take the square root. This will give us c equals square root of 36 minus 9, or a c value of 3 square root of 3. Remember, the foci are always along the major axis. In this case, we want to add and subtract that c value from our x coordinate of our center. That's what we've done right here. We've added to our x 3 plus or minus 3 root 3. That's just adding this c value or subtracting this value. And our y coordinate of negative 1 stays the same. We can find the decimal approximation of that. That's going to give us our foci right about at these points here. Alright, let's do another example. If you're a little confused, that's okay. Just center yourself and focus, because you can do it. So, we've got x minus 1 squared over 16 plus y minus 3 squared over 25 equals 1. always equal to 1. Starting with the center, we got our opposite of x is 1, opposite of y is 3. That gives us a center of 1, 3, and I put that right on our graph here. Next up, major axes and vertices. This time, we were comparing 16 and 25. 25 is bigger, so our major axis is going to be in the y direction, or vertically. Take the square root of 25. We get an a value of 5. Again, this moves in the vertical direction because it's under y squared. We'll count our spaces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Giving us a major axis length of 10 and vertices at the points 1, 8, and 1, -2. Next up, minor axis. That's going to be our smaller of the denominators. In this case, 16 under the x squared term, so our minor axis is in the horizontal or x direction. Taking the square root of that, we'll get our b value of 4. Let's count those spaces. 1, 2, 3, 4. 1, 2, 3, 4. Giving us a minor axis length of 8 and covertices at the points -3, 3 and 5, 3. Go ahead and connect the dots. I love that pot. Let's not forget about our foci. We get c squared equals a squared minus b squared, or the square root of the big number minus a small number. 25 minus 16 equals square root of 9, and a c value of 3. This time, since our major axis is in the vertical direction, we want to add that c value to our y coordinate, which is 3. The x coordinate stays the same, 1, comma, 3 plus or minus our c value of 3. We can get the foci of 1, 6, and 1, 0. And we've got a beautiful ellipse.